Hey guys, just wanted to pop on here and kind of go over your notes today since class attendance was super low today. So this is for Sustainable Agriculture. We'll go over this PowerPoint about soil very quickly today, and then your assignment will be a discussion forum that will be posted on the Moodle shelf for this class, as well as a YouTube video for you to watch. On Tuesday during class, we will have a hands-on lab about soil profiles and working on erosion. So hopefully all of you will be back on Tuesday for those classes and we can knock them out. So before we get started, I wanted to make sure that you knew the difference in between dirt and soil. So we're talking about soil, okay, and soil is used for good purposes. And dirt is basically just soil in the wrong location is dirt, or it has nothing can grow, or it's just bad. Okay, so there's a difference. So when we talk about stuff these days, we are talking about soil, okay, not dirt. All right, so soil by definition is defined as the biochemical weathered uppermost portion of the Earth's crust. Okay, you can follow along in your Intro to Sustainable Agricultural book, Chapter 12, and highlight or underline these things so you don't have to write them down or refer back to this PowerPoint that's posted. So soils are their own ecosystem. You know that we talked about ecosystems the last time that we were in class. And so soil is one of those key things, all right? Because the soil supplies nutrients and elements for things to grow and make sure that that soil is fertile. If it is not, then things will not grow and you will see discoloration of plants, discoloration of crops, or you'll have dead areas, or you'll have water runoff that's way too bad, or just a bad situation. Okay, so here is a kind of a little chart to look at. And so this is, hopefully you can see my mouse. This is just a tree with a fibrous root system. Okay, you can see there's multiple roots here. This is a fibrous root system, and so it goes down into the soil profile. Okay, this is what is known as a tap root right here. It is one individual root that goes all the way down to anchor the plant. A taproot you'll see in carrots, more vegetables, or weeds that you pull up in the grass. You'll notice they have that long stem, but most trees are fibrous roots systems because they anchor you down a whole lot more than that tree will not grow over. Corn is another fibrous root system as well because those have to withstand the rain and the wind and whatever else, water runoff or whatever else we throw at them. They have to be able to be stable. You can tell that this spread of the root system is much bigger, and so it'll take it a while to get to the rock. But sometimes rock is closer, and the fibrous root systems will just go straight out instead of down because it hits the rock, like in this example here. Down here, you read that soils provide a medium for plants. Medium is what? A growing media, like a texture to grow in. So bag soil or soil that you dig up out of the ground, they're all different types of mediums that we have, and we'll talk more about those as we go on. All right, so this is the next thing, and you can kind of see this is the cross section of the earth and kind of where soil plays a factor here. And so it is this black line actually in between the red and tan line that you see. All right, so we get to talk about my favorite thing ever, and this is where our lab is going to come off of is soil profiles. All right, and so you probably talked about this in science in like the third grade. So your soil profile is by definition, you know, we like definitions, is a vertical section through soil extending from surface to unweathered rock. Horizons are distinct levels of the profile, and so we'll talk about each horizon and we will go over again on this information before we present or do our lab, excuse me. Each soil type has a unique profile with different horizons, and we're going to talk about those. So I'm actually going to go on to the next before I explain these. All right, so here are all of your horizons. So if you basically dug to the center of the earth, this is what a soil profile would look like. So this bottom down here is rock. Hence right here, parent material or bedrock. hard solid slabs, big chunks of rocks will be here. But if you go all the way to the bottom to the center, it's going to be a solid surface. As you work your way up, you'll notice that the rocks start to crack and shape and cripple, and that is breaking it down so that you can move to Horizon C, which is your weather parent material, also known as bedrock, but the rocks are more spread out, less less rocks and everything like that. Okay, and then you go to B, okay, and Horizon B, which is known as the subsoil, or by kind of fancy terms, is the zone of accumulation of salt. Okay, so B is your subsoil. So a lot of times when you're planting a tree or planting something, you'll actually get to the B. You're gonna have to dig for a really long time to hit C, and then to hit actual this. I keep touching the screen. Sorry, guys. This guy, you will have to work all your way down. All right. Then, so we're at B. You still see a few rock, but not nearly what you hit in C. Then you move up to your topsoil, which is A, because we're working our way to the top. And this is where nutrients and salt leach down in the soil. Okay, and then your O horizon is known as your humus, or your very top horizon, what you walk on every day. This is what we interact with. We interact with O and A when you plant your pansies or your mums or, seasonal flowers outside. You typically hit zone A, or horizon A to be exact, okay? These can be referred to as zones or horizons, whichever ones, all right? So those are your subsoils. All right, now switching gears to, excuse me, let me get some drink. Soil orders, which are how we classify soil. Okay, and when we're talking about classifying soil, we're talking about your sandy soil versus your clay soil versus your loomy soil versus your rocky soil. There's different names and clarifications. We have 12 soil orders here in the United States, and we will review those. And the soil profiles can vary depending on the types of soil. And then mollisols are soil orders important for the agricultural production. You need to make sure that you highlight this definition because it will pop up here on out. All right. So these are soil profiles, as you can see. Glacial deposits are these little black dots. Okay, you have a dark brown firm clay, all right, a light grayish brown silt loam, and then humus material. Forest litter or leaf mold is up here because the leaves fall and they sit on top of the soil, and they actually can start to grow mold underneath them if it rains and the moisture has nowhere to go. All right, so this is if you were looking at a forest soil and they have a humid to a mild climate. But if you switched over here to the grasslands, you see that mollisol, which is the word that we just highlighted. They have clay and calcium compounds, and they are rich in dark soil and rich in humus, which is a great nutrient for plants and stuff to grow. And you can see that this is grass with a few rocks. All right. All right, so when we look at soils, we look at rocks and minerals, the organic matter, the soil organisms, soil pore space, and soil water. And so just like us, we have pores. Soil has pores, that some that hold a lot of water and some that do not. All right. All right. So this is if you like pie charts or you like to look at it other ways than just actual numbers. Solid versus the pore. Okay, the mineral material makes up 45% and 5% is your organic matter. If you split these guys, they look like they're split in half, but they're not. There's a little bit more gas and air. Phase is 85%, and then the other 15% of that is liquid. All right. So let's talk about rocks and minerals. Okay, so that was the elm. Think way back to the horizon that we just looked at. And the bottom section was the parent material of the soil is rock. Okay, there are 3 different types of rocks that you can see here. All right, and then we have 17 essential minerals for plants to actually grow. All right, so essential elements, pretty much what you need to write down and highlight is focused right here. and plants obtain carbon, oxygen, hydrogen from air, and others from soil. And then there's 17 plants essential. All right, so let me get my pen out here. Okay, hopefully I can do this. Carbon, oxygen, and then this is terrible, I'm so sorry. Hydrogen. Hopefully you can read that as G, and let me squiggle that out there. All right, and then this is the other one that you need to write down. All right, so there you go. I'm going to click through some of these and talk about what we need. All right, so soil micro versus macroorganisms that live in the soil. This is where your fungi and your bacteria and your leeches and stuff that you necessarily cannot see come in play. Also your chipmunks, worms, insects, mushrooms, ground worms, beetles. This is where they all come into areas. All right. So they can be either, again, fungi, bacteria, earthworms, insects, rodents, and snakes. These are all people that find a use for a soil other than growing. They find protection, or they actually develop in there, like the groundworms hang out in there all the time. That is a groundworm. All right. Soil properties. Okay, this is where you get texture, structure, and aggregation in soil chemistry. So first one is soil texture. Okay, so if you've ever felt sand, you can feel the actual particles and you can feel them run through your hand. But sometimes if you ever made mud pies with clay that we have here in this area, then you can't break those particles up. All right, and so clay is made up of a bunch of different things, but the main thing, soil texture, is clarified by three things: sand, silt, and clay. Okay, those are the three important things. I've underlined those. You need to know that. Soil texture comes down to three things, which are right here: sand, silt, and clay. All right. So we have different things. So clay is right here, super small. Silt is a little bit bigger. Fine sand, very fine sand, and normal sand. Okay, so you'll have this very fine sand in the eastern part of the state. Goldsboro, Kinston area has very fine sand, and then the bigger, just regular fine sand is what you see at the beach in the North Carolina coast beaches as well as South Carolina coast beaches. All right, this guy looks real complicated, but we are going to work on this in class with the lab as well. But just kind of quickly, I don't know if you've ever seen it, but this is what's called a soil texture triangle, okay? This is the clay side, the silt side, and the sand side. Again, those are your three main soil textures, okay? You got clay, sand, and silt. Okay, they go from 10 to 90, 10 to 90, 10 to 90, okay? And so basically what you're doing is you're connecting the dots, all right, to determine what kind of soil texture you will have in your area. All right, so it says identify a soil that is 40% sand, 22% clay, and 38% silt. All right, so it says start off by finding 40 on the sand, which is right here. Okay, and we're going to go up, and then it says do the same for clay, which is right here, and do the same for silt, which connects us all at one big point in the loam, okay? And so that's going to give you a coarse sandy loam, all right? So it is loam right here, all right? So I'm just clicking through this real quickly. You'll need. Okay guys, so I'm gonna wrap this video up and I'm gonna pop on another one and talk to you real quickly about fertilizers, which is the last thing that I want you to focus on for this chapter. Again, I want you to review the whole entire chapter 12, PowerPoint for Sustainable Agriculture, and then at the end of the next video that is posted, I will explain your assignments to you.